So here's what's going to happen. I'm going to go over this. It's going to be pretty straightforward. There should be a new set of notes called Unit Conversions inside of your engineering notebook. Inside of your table of contents, as well as a title, should call it Unit Conversions. It should be in the live video. If you guys look up live stream or the drop down for live streams, it should be there any second now.
Is this basically dimensional?
Yes. Just watch. That's all I'm asking you to do. I know some of it's really, really old review for some of you guys, but call it Unit Conversions. Yep, Unit Conversions. Oops. Goes on or no? Not coming up. Should be dropped down from uploads. Go to live streams. It shows me being locked down there. The red. And go to streams. Oi. And now none of them will work this time. No browser. Google is not the thing, like, it's everything now, so they can't go to YouTube. Some of them are getting able to do this, and some of them are not.
Do they type in YouTube.com?
I just went over there and did it. I did YouTube.com.
My kids are trying to type in, like, classroom in Google, and it's not. Oh, yeah, Bing doesn't work.
Well, I'm not doing that. Nobody can see the stream then? What's going on? Seriously? You got one person?
Yeah, this video is not available. Oh, it just came up for me.
Okay, refresh. Seems like it's coming. Mute me, please. Okay, guys, so here we go. I'm just going to make this short and sweet. I'm not going to go crazy detailed. Please mute me for the 4th time. Oh, my goodness. So, in unit conversions, these are, again, a lot of you guys are going to look at this and laugh because it's very, looking for the lamp, sorry. It's very, like, reviewish, right? So, dimensional analysis is what it's called. Basically, what you're going to go through and put in your engineering notebook, again, is unit conversions. Make sure you put that in your table of contents. And then we're going to take a picture of this, all your answers later, and make sure you put it into Google Classroom, okay? So, what this is basically, I call it a formula, but it's not called a formula. It's basically just a standard in a sense, right? So we have a unit given to us, and we're trying, what's that? I would, yes. I would write, obviously, this little system down right here, okay? Dimensional analysis, given units over 1, multiplied by desired units, divided by given units will give you what you're trying to get in the end. Okay? This is called a conversion factor. And what you guys are going to see in Google Classroom is under resources, you'll see it in my stream that on the right-hand side there I have a formula sheet. In resources, there is a formula sheet. You are able to use this formula sheet throughout the whole entire year. Okay? On tests, pretty much everywhere. So in Google Classroom, I want to make sure that everybody knows where that's at. In Google Classroom, you guys are going to see in 4th hour, inside of classwork, inside of resources, you'll see engineering formula sheet right here. You click engineering formula sheet and it's an 11-page document. Now, I know this is a little overkill, This is for all 4 years. Use the same exact formula sheet. On page 3, I believe it is, yes, page 3, you will see conversions and you will see prefixes. Those are the only 2 things that we're going to use today anyways. Okay? This gives you basically everything you need to know from conversion rates to actual just moving decimal systems. So rather than, again, go over that, I've already created and put that over here just so I can reference to it back and forth. So I'd rather, instead of going over the 48, and I'm not exaggerating, the 48 PowerPoint slide that they have for you for this, I'm just going to show you some examples, and if you have any questions, you can ask them. Is that fair enough? Does that sound better than me sitting there going through a PowerPoint that nobody's going to listen to? Yes? I would write down this, yes, the given thing, the given desired units, and you can get that later when I'm done here. So basically, first kind of rule. If you're trying to go to a bigger system, you move the decimal place to the left. If you're going smaller, you move it to the right. It doesn't work all the time, but 99% of the time it works. Okay? And what I mean by that is basically if you have a common unit or a common root what's it called? Unit, basically you can just move the decimal. It's super easy. Okay? So for example, convert 103.2 centimeters to meters. If I go to my little chart over here, you can see centimeters is right here. Okay? So under centimeters, it says 10 to the second power. You could do the math like I showed you using this factor form here, the conversion factor. You could say 103 centimeters, this is my given. This is what I'm trying to get to is in meters. And then again, this is what I'm given. You cross multiply to get your answer. You can do it that way. Or, the way I do it is I take 103.2 centimeters and I say, okay, if this is 10 to the negative 2, I'm going from a small number to a big number. So I'm going bigger. I'm going to move the decimal place left, whatever this power is. So in this case, 2. So I'm going to go left 1, 2. And my answer is 1.032. You guys see how easy that is? To me, that's easier. Let's do another one. Convert 0.005 kilometers to centimeters. So I'm going from a big to small. I'm going smaller. I'm going to go right. So in this case, I'm going to go kilometers first to just the root. And where the root is over here again on this. It's in the center between these 2 charts. So if you look at it, it says, you got your decas, your centa, all your prefixes, your root, your meters, your inches, your all that kind of stuff are all directly right in the center here. Your grams are on the middle. And then it either goes bigger or it goes smaller. So in this case, we're going from kilo to a root first, and that's what this math shows basically, is we're going for kilometers. This is what we're given. We've got to get to meters first, which is our desired. This is our given. And then once we get that answer, which is 5 meters, we're going to take then we have a given, desired, and given. And then you just basically divide in this case to get your answer. That's a lot of math for no reason in my mind. Okay? Instead, what I do is I say, all right, kilo is 3. We know that from this power right here, right? We know that's 3, and then from there we still need to go to centimeters, which is another 2. So that's 5 total, right? Watch this. 1, 2, 3, 4, 5. If I move those 5 decimal places, I get the same answer as 500 centimeters. Does that make sense?
Yes.
Because I'm going from a big number to a small number, I'm going to the right, like it says in my little notes right here, and it's way easier than doing all that math. Good so far. Any questions? Okay, next one. Same system. We're going from hecto, but what happens if they're on the same exact side? So if I go over to the right side in this chart over here, hecto is 2, and then it says mega, because it's a capital M, is 6. What's the difference between 6 and 2? 4. So I'm going from a bigger to a bigger. So I'm going to go to the left in this case. I'm going to move it 4 places. So 1, 2, 3, 4. Look at that. That's my answer. Or you could do all the math. I'm not doing all the math. Why do more than you need to, right? Does that make sense? Okay, those are easier ones, right? They're just moving decimal places. What happens if you're not in like terms, right? Let's say you have in yards and feet in this case. So we have 17.2 yards and feet. How do you know how many feet are in a yard? Eventually, you could either just memorize it, which, look at the chart, it says 1 yard equals 3 feet. So again, you have a given, you have a desired, and you have a given. Okay? So we have yards. We're trying to get to feet. So how many feet? 3 feet into 1 yard. So these cross multiply. They cross out. You're left with feet. In this case, we multiply 17.2 by 3. You get 51.6. Pretty straightforward. Next one. 3 feet. 3 feet and 7 3/4 inches to inches. So we have inches, we have inches, we have feet. If we're trying to get as a final to inches, we have to get this feet to inches first. So we have given, desired, given. You're given 3 feet. There's 12 inches in 1 foot. Look at a ruler. And then you're just going to multiply across. 12 times 3 is 36. 7 3/4 stays the same because that's already in inches. You add them up, you get your answer of 43 3/4. Pretty easy? Any questions? I know this is really reviewish. Next, 34.7 to centimeters, so inches to centimeters. Again, I look at my chart. My chart says it's 2.54 centimeters equals 1 inch. I have my given, I have my desired, I have my given. I multiply across 2.54 times 34.7, I get my 88.1. Let's go to a double one. Those are all easy. Now let's start to get a little bit trickier. These are more ACT-ish kind of questions. So now we have inches to yards, right? If you look at the chart, you have inches to centimeters and you have yards to feet. What's the like variable there? What can you mess with in order to make those two eventually match up? Feet and inches, right? So in this case, I have inches to yards. So I have, again, I have to get to feet first, and then I can go to yards. So I have to basically cross multiply to get the numerator and denominator the same, so I can cross them out to get my term that I want. So again, given, desired, given. 345.7 divided by 12 inches, there's 12 inches in 1 foot, to get 28.8 feet. Now I have my given, my desired, and my given again. I can cross multiply and say that feet goes away and yards is left. 28.8 divided by 3 will give you 9.602 yards. Let's go into one that has actual purrs, I call them. Cats. Sorry, that wasn't funny. 55 miles per gallon. Convert kilometers to liters, or kilometers, liters. Okay? So now all we got to do is, this kind of breaks the rules a little bit. Now we have to make sure that we can cross multiply to get rid of these miles and gallons to eventually get kilometers to liters. And I know this is broad again, but if we got to go first, let's do gallons first. It's in the denominator. We got to have gallons in the numerator. So how many liters and gallons we're going to say later, because we're going to go liters eventually. We can then cross out liters. This is what we're trying to get. This is what we were given. So if we're trying to get to liters, there is, if you look at the chart, 0.3 or 0.264 gallons in 1 liter. I can multiply 55 times 0.264. I get a number. And now I have liters. Again, if I'm already in liters, now I'm going to get to kilometers. So I'm going to take the kilometers, what I'm trying to get, and I'm stuck with miles still. Keep going. So now I have numerator on top miles, denominator on bottom for miles, and cross multiply those. I'm left with liters on the bottom, kilometers on top, and I'm left with my final answer of kilometers per liter. So I multiplied 55 by 0.264, and then I took that number and divided it by 0.2621 to get 23.4. Does that make sense? That's all I wanted to do. Just show you guys some examples. That's how I think it would be easier for me to do. Okay, so in the activity, basically all you're doing today is, if you guys look at Unit 1, you're going to see unit conversions. And you're going to see this activity, 1, 2, and 3. A, B, C, A, B, C. You're going to convert all these, and then you are going to basically do these little story problems, and we're good to go. That's going to be in your engineering notebook. Okay? The catch is, for A specifically, I want to make sure that you guys are clear. It says 4 and some of these are like this on the EOC, so they try and trick you. 4.67 trillion. It also shows in parentheses the actual number. 4, 5, 6, 7, comma, and then 9 zeros. And I want to show this on the doc cam here. Okay? So these are the two numbers. Which number do you think would be easier if eventually, like it shows here, it gives you then meters, right? to me, and then you're trying to go to gigameters. To me, it's a heck of a lot easier to work with this number as it is this number, because all you're going to do is move the decimal place, right? So in this case, if the decimal place is here, first off, you'd have to do this trillion meters. I'm like lost. I don't know. I don't like that. So I use this whole number right here. There's a couple of them like that. One says trillion, one says billion. Make sure you do this first so that when I go to giga, I can then just move the decimal place how many times I need to make it easy on myself. Does that make sense? That was the number one question on the activity, first problem. Good? Okay, the rest of the class you guys have to work on the activity, okay?